Am I audible? Is it getting recorded?
Yeah, it's recording and you're audible too.
Yeah, so we can start now. From the first question is like search in a binary tree. So if we see here, we are given the root node of a binary search tree and a value. We need to find the node in the BST that the node's value equals the given value and return the subtree rooted with that node. If it exists, if it doesn't exist, we need to return in that case null. So here, this is the tree and the value to be searched it to. So we need to return this particular rooted subtree, that is 213 they have returned. And if you want to search value 5, since we don't have anything, so it will return null in that case. Note that an empty tree is represented by null. Therefore, you should see the expected output to be in this form. Yeah. So, any queries or how do you approach?
So this is a binary search tree. So, and then we are giving a value which will be the target. And the problem statement seems to be very straightforward, right? Like if you have a value, if you can find it, just return that value, return the node, and or else you return null. Right. So
I think.
Sorry, go ahead. If you don't find it, you are just returning. You should return null.
So it's very intuitive, like how you do binary search kind of things. Suppose if your key is something, and if you go into the root node, if the key is greater than root node, you should look for the right subtree. Otherwise, you should look for the left subtree, or is equal to then return that tree pointer itself, right? So I think it's very simple questions, and it can
Yeah,
be solved.
yeah, that makes sense. And I think that is the only way we could actually resolve this. There might not be more approaches, either than using a recursive or, I'm sorry, who is it? Shashank? Shashank, are you talking or? I think we lost him.
But we can see his screen, right? So
yeah, but sometimes his audio is.
Song, if you are listening to us, then your voice is not audible to us. So check.
Yeah. Okay, maybe Shashank, you may have to log out and log in again. Yeah, so in the meantime, Nitesh, I think you said about that approach, right? You go through the, that makes sense. So there would be only this approach, right? Either you do it a recursive way or iterative way.
Or iterative way, yes.
Yeah.
That will work.
And other than that, I don't think there is any way we can solve this problem.
Yes, other that, yes,
Yeah. So do you want to, I think let's see what he is saying in the chat. It seems, oh, he's rejoining. Okay, no problem.
Okay.
So do you have anything to share? You want to share something, Nitish?
Actually, I have solved this problem. So it's like a 4 line of code. Okay, I will share this.
Yeah, please go ahead. Yeah.
Actually, I don't remember the questions. What was?
You want a question number?
Yeah.
It is 700.
So Santosh, are you using Python or C++ or Java for your?
I'm using C++.
Yeah,
But
then
you
it will
can
be making more sense. Yeah.
Yeah. So even if you have Python, should be fine because Shashank usually uses
Yeah,
Python.
yeah, yeah.
Yeah.
Yes, yes. But sometimes it's too high level, right? So we miss some things in the Python. So
Yeah. So it's interesting to know about that also.
yeah, yeah, yeah. Can you see these questions in my screen?
Yeah. Yeah, it's visible.
Yeah, this one, right?
Mm-hmm.
So basically what is happening, so we have given the pointer to the root, right, and one value.
Mm-hmm.
So it's like forget about the base case right now, this one.
Okay.
Just check this. If this value is equal to the root value, suppose if I'm searching for the 4, if I found the 4 itself, then I will return it from here itself, right?
Right. Right.
Since it's a binary search tree, so definitely the right subtree will be having always greater than the root element, right? So suppose this value is having the greater than the root dot value, right?
Mm-hmm.
Then I
Mm-hmm.
should look for only the right subtree. Else we should look for the left subtree, right?
Right.
So it's
Right.
like a, it's suppose for the trial and purpose, if you want, suppose if I'm searching for the 2, right?
Mm-hmm.
So my root node will be at initially it will be 4, right? So
Mm-hmm.
root equal to null? No, it is not null because it is pointing to somewhere like 4. So it
Mm-hmm.
won't execute this. It will go here.
Mm-hmm.
Is equal to 2 is equal to 4? No. Again, it will become false, right? So it will check this condition. If value is greater than root dot value, I am searching for 2, but this has 4. So it is again it is false, right?
Mm-hmm.
So it will go to left subtree. So the root dot left is nothing but this subtree, 2 to this one, right? So once
Yeah.
now my root will become this 2 itself.
Ah.
So now value is 2 itself. So if this condition will be satisfied, right?
Line
And it will
16.
return
Okay.
the root. Yeah. And it will return this subtree. Else if it not found, so finally this null will be returned to this. So anyway, this will work.
Yeah. I think makes
So
sense.
Sasank, are you there?
Yeah. He just joined in. Hey, Shashank, can you hear us now?
I think.
I can.
Okay.
Okay.
Good.
So now it's up to you. Who's
Yeah.
talking?
So the other way would be, use sort of not an iterative way, or yeah, maybe not an recursive way. So in that also, it would be very straightforward, right? The similar
Yes.
approach what you showed, Nitesh. All right, just
Yes. Yes.
put a while loop,
Yeah. Yeah. Yeah.
yeah, and just look for those base conditions, and based on the value of the root, just either move the root to the left or to the right? So that should
Okay.
also be about 3-4 line code.
Yeah, he has done actually. So yeah, I mean, I think Sasank's screen, right? So he has done in
Okay, yeah.
iterative, like a while.
Oh yeah, good. Yes, Shashank, go ahead.
Yeah, it's like same what Nitesh was almost. I mean, as long as you find that your root is not null, the moment you find that this is, I mean, 2 you found here, then you just return root from there. If it is less than your value, you just go to the left, other go to the right because of the property of the BST. It's the same.
Yeah.
I mean, whatever.
Yeah.
So this is the
Hi.
in order, right?
Okay. Yeah.
Oh, sorry.
It's
This is the pre-order, right?
It's like a
yeah,
pre-order. Yeah.
Yeah,
root left right. Here.
right. So I think we can do it by in order and post order also.
Yeah,
I
definitely.
mean,
Like in both the case, you are traversing.
Yeah, won't make any difference.
Yeah.
But
won't make
I mean, more computation you'll have to do in case of post order and all. Like you will go to leaf and then the
Right,
root.
right,
Here
right.
you
That would be O of number of nodes, right?
exactly.
And this is O of log n if the tree is balanced.
But
Yeah, makes
will the
sense.
both traversal will not be the same? Why this should be different?
No,
I
but
mean,
yeah, because we won't be able to take care of this condition.
see,
Uh, the root of val greater than val if we do it some other way.
in
Under
order,
travel.
actually, we don't discard the tree, right? Suppose here we are discarding the subtree, which is, I mean, I am sure this won't be a part of it, right? So I'm discarding at each step half of the tree. But if you go with the in order, then we are not discarding anything. We are just iterating through all the nodes, and we are
exactly.
finding. So
Oh,
that's actually, yeah.
no, I missed that point. Okay,
Number
good.
of nodes will it have?
Yeah. Now I
I
got
will
it.
just
Sorry, I couldn't visualize that earlier, but it's fine. Yeah, good. Yeah, thanks for bringing that. And now, what is the time complexity of both of them?
N only,
I
order of
mean,
n, we are traversing all the nodes.
no O of log n.
No,
no,
O of
this is
log n.
log n, right? This is log n, Sasan.
O of
What you
height.
have,
Yeah, O of height or O of log n.
Then okay, worst case, let's see, 2
Yeah,
is
worst.
your, I mean,
hmm?
Yeah,
if
if
it
it's
is
a
a
skewed
2, 3,
tree,
then
then that would be O of n.
yeah, so we have to take that, no?
Yeah,
No,
but we
yeah,
can always say average case first, and then in the worst case we can have, but because worst case don't happen always, right? So,
But
but
we
we
have to,
can,
for time complexity, we'll have to say for the worst case only, right?
You
Or for,
always, yes.
so we can say
That's
O of
actually
height.
valid point.
O of height would be right. We're saying.
okay. Yeah, O of height is a
Yeah, that
common,
will,
common
yeah,
word.
Yeah,
that will
please.
make more sense.
but O of height is log n, right? So,
No,
Here
Not
it
every
height
is,
is
time.
not always log n. Height is
yeah,
log n in case of balanced binary trees, balanced
right,
trees.
yeah,
but
So
in
in
case of
case of
skewed,
skewed
we'll have
tree,
n.
O of n. Yeah,
Yeah.
then
okay, yeah, but we can specifically mention, so at least we know that the
yeah,
solution is very optimized version. It's not
right.
the normal one, the brute force way. Yeah. So the other way would be, like go through the whole node root tree, you know,
Okay.
and just collect everything in a vector or an array, and then just traverse that array, and then find the value.
Matching, yeah.
Yeah, but that will
It's
be a
like you're doing the same thing twice, right? First
yeah,
you are iterating through everything, then you're searching.
yeah. In worst
We can
case,
do
if you are not
binary
able to
search
come up,
in that case, I think.
yeah, you can do
But
binary
it
search
will
in that
be,
array.
yeah, you can do. I mean, yeah,
But that's the worst case, it's not a good
Yeah.
option. Yeah. Yep. So that's cool.
Can switch
next
to next.
question.
Yeah.
Yeah.
Yeah. So random point in an non-overlapping rectangles. We are given a list of non-overlapping axis-aligned rectangles. We need to write a function pick, which would randomly and uniformly pick an integer point in the space within the rectangle. So some of the nodes are there. Integer point is a point that has integer coordinates, and a point on the surface, perimeter of a rectangle will be included in the space covered by this. And a rectangle of I is denoted by this, where these are the integer coordinates, bottom left and accordingly are the integer coordinate, top right corner, whatever. And
Hmm.
length and width of each rectangle won't exceed 2k, and length is less than this. And pick a return point, such as these coordinates, any coordinate, and pick is called at most 10k times. Yeah.
So that means
So
it should be very optimized, right? The way you're
exactly.
saying on the seventh. Okay.
Yeah. 7. And yeah, so for this you'll have this like, so what would be your the input in the tool is the subroutines called their argument solutions constructor as one argument, array of rectangles. This will have no arguments and are always wrapped within a list if there aren't any. So
Yeah.
what would be the approach? Yeah,
So it's a very lengthy problem statement. Yeah.
exactly. Yeah.
So, but the only thing what it boils down to is you have a non-overlapping rectangles. So they are not
Yeah.
overlapping. And we need to actually find a random point in any of those rectangles, all of the rectangles anywhere. But we can include the perimeters also. So that is also an important pointer, right?
Yes.
Yeah.
Yeah. So we just find it randomly and the probability and everything should be,
And but it should be informally picked, right? So it is saying it should be only informally picked from those rectangles. Suppose we are putting 5 times pick, so it should be eventually distributed through all the rectangles.
yeah.
The points will come from all the rectangles, right?
Hmm. Yes, we should not be outside the rectangle. Yep, makes sense. So I just looking at the problem, it's
Actually, I solved this problem, but actually I am getting wrong answer. I don't know where I missed that logic. So, if, I mean, should I go through? Then anyone can correct me where I missed those things.
no problem. But can you first explain what your approach is?
Yeah, yeah. Actually, that will be very easy to explain me to the code. Actually, I can explain it this also.
Okay.
I will go to the approach only. I won't focus on the code basically. So basically, this rectangle, if you see, there are
Can you
four
bit
points,
increase the
right?
font size? Sorry,
Okay, okay.
a bit. Yeah, that's enough. Yeah, thank you.
Okay. So basically, it is saying they have given me as a 4 point, right? I mean, it's like a vector of vectors. Suppose so, it is a vector of vector, right? So this vector will be consisting of 4 points, that is x1, y1, x2, y2. If you see, it is clearly saying this x1 and y1 are integer coordinate of the bottom left corner, right? So it's like a bottom left and the top right. So relatively, if you see, this x1 will be always less than the x2 and y1 will be always less than to y2, right? Relative position, if you see.
Yeah.
Okay, yeah.
One is
Right?
left, other is right. So left is less.
Yeah.
Yeah.
Right, and that's to bottom. So it will be always, I mean, both x1 will be less than the x2 and y1 will be always less than y2, right?
Mm.
So what I have done, I created an object of rectangle, picking this all those 4 points, right? And currently what I'm doing, suppose if somebody is asking me give me a random point, right? So I start from the bottom left, from this corner itself, right? Like suppose this is I slice this rectangle with all those 4 coordinates, the same what is given in the question, right? And I'm taking this current x and current y as like a x1 and y1. So whenever somebody is asking me a random point, give me a random point, what I will do, I will check whether this cx is less than to x2. If it is there, then I will increment this and I will return this a point, because this will be also a valid point, right, in the rectangle. Until unless
Sorry,
cx is less than x2.
one doubt is there here. Like,
Yeah.
in question is written that it should be with equal probability, it should return the points. But if you, that what I am seeing in the code here, how can you ensure that it will return with equal probability the points in the rectangle?
Yeah, I think he's explaining, Ankur. So let him first finish
Equal
that.
probability of, so it should pick from each rectangle, right? That's what you're talking about, right? Write a pick function which randomly and uniformly picks an integer point in the space covered by rectangle.
But when you say randomly and uniformly picks, that is what
Equal
Ankur
probability.
means. Yeah, that is what Ankur means.
Exactly.
Okay, so you are saying it will give me a point, but it won't give me the uniform, right?
Right,
Yes,
right.
yes,
Yeah.
equal probability.
Okay, okay.
So
So
that is the yeah. But
I missed
Crux.
this point basically.
yeah, no problem. But can you just go through? Now you already have that, so we can just have a
Yeah.
separate approach.
So actually, it will be a valid point, right? Any point less than x2 and y2, it will be valid point. So I'm returning this point, right? So similar way, if suppose cx is full, cs reaches to the limit of x2, right? Then I can increment y2, right? Until unless I can go up to top right, right? So I'm returning this. If both have reached to the right, to the top right point, right? So but still it is saying peak, peak, peak. So it has to be repeated, right? Those points has to be repeated. I don't know whether this case will arise or not, but on the safe side, I put it like this. So again, I initialize with cx is equal to x1 and cy is equal to y1, and I return this. The same process will be like looping, through this. So that's what I've done. But actually, yeah, I think I missed this point. Uniformly picks an
Yeah.
integer.
Because some
Otherwise,
test cases it might pass, but it won't pass for all of them. So
yeah.
So if you use a random function, then it will actually make more sense. Yeah,
Okay.
that's a good try. Yeah, no problem.
To
Yeah. So yeah, the other approach would be, what we can do is, first we need to find how big our area is. So we need to take into account of all the areas of each and every non-overlapping those rectangles, sum it up, okay, and then we need to have a random point in that area only. So
but
when we
again,
have
how you
that in that area, so but then we need to find out which rectangle, non-overlapping rectangle it will lie in that, right? So we need to go and access that, and accordingly we'll have to return the point, because we need to validate it is actually in a specific rectangle. So for that we'll have to use some sort of a searching algorithm, and then we can return it. So if we do it that way, so your pick can be optimized. We can do the pre-processing of getting all those non-overlapping areas in our constructor itself, so we don't have to do it again. But only for the pick we need to go and find a point what is generated by a random operations, and it lies in a specific rectangle. For that we need to search in those list of rectangles using our average, using our sum what we had already pre-calculated, right, Shashank?
Yeah.
Yeah.
I have some doubts understanding the question. Can you please explain example 2?
example?
Okay, example 2, you have two rectangles, right? One is which starts from -2, -2 to -1, -1, and 1, 0, 3, 0. So they both are non-overlapping, correct?
Right.
So we can actually find out what is the area of both the rectangles. So in
I
this
mean,
case,
Can you
yeah,
share the screen? I think.
I think area. Okay.
oh yeah,
Santosh
okay,
is
there's
telling
no,
nothing.
Like
Basically, what
blank.
I'm not getting that why we need area. That the
Exactly,
first
yes.
thing.
I don't think we need area because we are doing it in reverse way kind of thing. But I mean, it doesn't make any.
You
So
need to uniformly
actually,
pick, right?
yeah, if you
So
have,
Yeah.
yeah, so if you need to pick uniformly, it needs to the point should be, should be equally probable that it should be present in every rectangle or every possible space. So for
It's
that, you need the area.
yeah,
Yeah. So basically, it gives us a mapping to,
yeah,
I mean, mathematically weigh things in this
yeah,
case. So a rectangle with a larger area would be more probable to be selected. I mean, a point in that rectangle.
correct, correct.
So that is why we kind of deal with areas, and we kind of try to make that rectangle way
Yeah.
through its.
okay, yeah.
I think what Ronnie is saying,
okay.
like if
Okay,
you
now
have
I'm getting it.
two
Yes, 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 yes.
rectangles,
Now I understood the questions. Yes, yes,
yeah,
yes, yes.
one is small and one is big. So if we have about 5 to 6 points, so if we have a
Okay.
5 points, one will be here and at least four should be here based on the rectangle size, correct? So then the probability will be uniform.
It is the question of
Yes.
probability.
I'm
Yeah.
sorry.
Like we have to satisfy the condition of probability, equal probability. Therefore, we are
Yes,
taking area, right?
Right, right. Because
yes,
they
yes. I
should
got
be
it.
randomly and uniformly picked, right? So they should be uniform across all the rectangles what we have. So we are assuming that all of them will be of the same area, but it won't be like that. So it can be of any shape and any sizes, or any size, not the shapes. It's always going to be rectangle or square, maybe max. So that is the only main trick in that whole example. And therefore you need to have, if you have this area, so this is area 1 and this is area 2. If you have two of them, if you have a sum of both these areas, which will be A, okay, which will be A1 plus A2, right?
Okay.
So in that case, when we do a random, we just generate a random function, we can find out where actually our point will lie, So based on that, we can find out which rectangle it is lying. So to verify whether it is lying in the rectangle or not, right? So we need to verify that, and then only we can return that value.
Yes.
So that is only we have to use those rectangles.
Santosh,
Yeah, sorry.
one more doubt. I mean, if we pick a point from one of the rectangle, So does the probability need to decrease if from that rectangle, if I call the next pick again?
No, if you do that, then it won't be the same probability, right?
But how will you make it confirm that you are picking again the point from some? That's a random picking, right?
No. I was actually
Yes,
telling.
I mean,
Yeah. Sorry, what?
so
Like,
coming to Uday's question, right? I mean, it won't decrease the probability. Suppose, I mean, it's like suppose you are called 10 times peak, right? And this area, suppose I'm taking this large one like area A1 and small one is area A2. If you calculate the ratio of area A1 by A2, it's come like 8 is to 2. So 8 times those numbers, those I mean those coordinates should come from this area A1, that is rectangle A1, and 2 times it should come from A2. So it's like that actually.
Yeah, so if you actually have a pick from a particular point, and again, if you want to take care of that, it should not, same point should not come. Actually, that won't be a uniform pick, right?
No. I was actually saying the probability should reduce. I mean, if I call up the pick next time, the probability of that point appearing from that rectangle should be decreased, right?
It will depend based on how big the square is.
It's a uniform distribution.
I mean, currently it's on the area itself, right?
Yeah. So in the area itself, but if I think in the area A1, if it is exactly 4 times that of A2, then we should have, when we have a distribution of those points, they should be uniformly distributed based on the density, right?
Yeah, because you're dividing by total. You have already calculated the total area, so there is no point of non-uniform, right?
So that is what I understand. Yeah, sorry.
I will try to explain my scenario.
Okay,
so
do you want to share the screen?
No. Just a doubt itself. So let's suppose there are 4 points in one rectangle and there are other 4 points in another rectangle. So if I call 8, I mean, almost all of them should have appeared equally, and if I call the next 8 on the 9th time, the probability should get reset, right?
No, we are not changing the sample space in any way.
Exactly, yeah, that is fixed 8.
Yeah,
When
so
you
we're
are
not
calling the 9th also, it will always keep coming from the same, because you are not restarting the whole application again, right?
No, we are picking uniformly, right? I mean, suppose let's say let's represent it like this itself, 1, 2, 3, 4 itself. Now I want to pick a random number out of this 1, 2, 3, 4. Now I have picked 2. Now 1, 3, 4 should be equally probable. After picking 1, 3, 4, now 1, 2, 3, 4, each one should be equally probable, right?
Well, can we take an example?
So when you picked 2, the probability was 1 by 8, right? Total area was 8 and you picked 1 point out of it.
No. I will try to tell you with an example.
Okay.
So let's take 4 integers, 1, 2, 3, 4.
Okay.
Quite let me. Is this right? 1,
2. Okay.
Sorry.
It's difficult. Okay, sorry.
Yeah.
Let's pick 3 integers. So 1, 2, 3. I mean, you can write it anyway. Either I, something like that.
Okay. So how many integers you said? 1, 2.
1, 2, 3.
Okay.
Yeah. Now I have picked randomly 2.
Okay. Let's do one thing. Let's do one thing first. Let us decide on the rectangles. Okay. How big the rectangle we want to? The first rectangle. Let's only take 2 rectangles. Okay. And the first rectangle should be as of the same area as the second one, or you want both to be different?
No. I'm trying to tell you with an example. I'm trying to tell you with an analogy. So let's suppose these 3 are integers that I'm trying to pick a random integer from.
Okay.
So
Okay,
if
so
I
you're saying you only have 3. Okay.
Yeah.
Okay.
Now I have done a random select and 2 has been selected. Now 1 and 3 should be more probable than 2.
No, it's equally probable. Next time it's also 1, 2, 3.
Yeah.
Equally probable. Yeah.
You are
It
not
doesn't.
throwing
I
that
mean,
point out
2
of
has been
this
selected
rectangle,
once,
right?
right?
Yeah, it
No,
has
no,
been selected, but next time it's gonna be uniformly still from 1 to 3.
From the
Equally
same
probable.
collection. Yep.
See here, probability of each point is 1 by 3, right? Let's say if the area, total area is 3, then 1 by 3 each of the points will have, right?
no, that is correct. Yeah, 1 by 3, 1 by 3, 1 by 3. But
Okay.
if I
Now when
have
you
selected,
picked 2,
yeah,
okay,
so
now you
1 and
pick
3
2.
should be more probable, right?
No, but you are not throwing that point out of the sample space. No, that
Yeah,
point is still, you're
sample
just selecting
space
it.
is remaining
It
the
can
same,
repeat
right?
in this
Sample
case.
space is constant actually.
Yeah, if you will throw it, then the probability will change to 2 by 3. Otherwise, it will be again 1 by 3 only. It will be equally
Yeah.
probable until unless you throw these 2 out of this area.
Yeah, actually, I understood it that way itself. I mean,
I think
every
that is a
point will
different
be equal.
problem. Yeah. This for this we have to do it always. Take it from the whole collection.
Yeah.
I think for this problem, we have to figure out if you're gonna store all the points or you're gonna store the length, like of the interval. Because if you store all the points, then when you pick the randomly, then you can choose one among all the points, right? But if you store only the length, then how you gonna pick like which interval? That's the crux. I feel that's the difficult part of the problem.
Storing the length actually. Okay, so we already have these areas, right? So I understand
Yeah.
what you're trying to come with, but what
Yeah, I mean,
I
area or length, I mean, this is, you can think of a one-dimensional problem. It's the same, but essentially you're picking, the problem is how do you, so let's say my random generator generates some value, right?
Mhm,
But
mhm.
what is that value? Is that value gonna be the point themselves, or is that like, do you see what I'm saying? Like
Right.
what does it return exactly? Yeah.
It returns the point in any of the rectangles.
But it's gonna be the point value, right?
Yeah, it should be the point value. So you
So
have to
then
have
we need
x and y coordinate.
then we need to store, we're gonna have to somehow store all the points, right? If we don't store all the points, how you gonna generate,
No, so what you are trying to say is when store in the pick function, you want to store what you are returning back.
no, I'm saying, let's say you have x1, x2, right? And then you have x3, x4 somewhere else, right? So now if you don't, if you only store x1, x2, and then x3, x4, right? Then your random function can give you like, it's gonna be uniformly distributed, but it's based on the difference of x1, x2, and x3, x4, like the difference. But from the difference, you have to map it back to what that value is, right?
Oh, so say now when you are saying x1, x2, and x3, x4, so what are
Yeah.
those? Are those points of the pick which you are returning, or are those points of a rectangle? Which
Points
you
of
are?
the rectangle. Let's say we have,
Oh, yeah,
yeah,
yeah. See, what actually when I went through one of the solutions, what I found, and it was slightly made more sense. So you already have these rectangles, okay? So which
yeah,
are with these coordinates. Okay, let's take the example of two. Okay,
sure,
so we have two rectangles here.
yeah,
So you need to do is you need to actually find some sort of a complete area. So you need to include both of these area. But
yes.
still, when you are selecting the point should be in either of this rectangle or this rectangle only, right? So for that
Yeah,
you need to come and verify here.
but I don't think you can pick, like, you have a rand function, just pick the rectangle first and then
Right. You have
pick,
to.
because then it's not uniformly distributed. Like the second rectangle area may be smaller than the first one. So the uniform should be on the sum of the two areas
Yeah,
combined.
absolutely. Yeah, absolutely. So first you need to get a sum of both rectangles, and then you need to find which rectangle. Then you run a random function and find in which rectangle you want to go. And when you go in that rectangle, you need to again run two random functions to find what are the x and y coordinates will be.
But how do you find which rectangle to go?
Can I share my screen?
Yeah.
Sure. Okay, let's finish this one. This code.
Go ahead, Praveen.
Okay. Yeah.
So let me share that. So do you guys see my screen?
Yeah.
Okay. So let's say we do have a rectangle. This one. And this one. And let's say this one, right?
Okay.
So as someone says that, okay, let's first calculate the area of these, and then add that sum that area. So that will make your sample space, right?
Yes.
Mm-hmm.
So now let's say the area for this one is 30, and this one is also 30, and this one is, let's say, for 30 also, right? So your sample space is 0 to
90.
90. And now you know that the first 30 is for rectangle 1, second 30 is for rectangle 2, and third 30 is for rectangle 3. Right?
Wait, how do you know the second 30 is for rectangle 2? You have to store that somewhere, right?
Oh,
Yeah, that is
you
what I'm
have,
saying.
yes, you have to keep that information that, right? So
Like
now,
a pair of area
Maybe
and
have a
some
prefix sum.
yeah,
Prefix sum of the
whatever,
array.
I mean, for 0 to 30, you know that that is rectangle 1. And if something comes from 30 to 60, that is R2 and R3, right? That information you have to keep. Now you run your random function, and let's say you get this value, right? So when you get this value, so you know that that point belongs to R2, rectangle 2.
Okay.
And now you can convert this function into a 2-dimension. This point to a 2-dimension easily, right?
2-dimension means like.
Oh, she's saying first you select that rectangle, and
This
inside
is
that
your
rectangle,
this is your 2D array, and you have R and C. So can you convert into, this is a single dimension?
Yeah, flatten it. Okay.
Right? The same way.
Plus columns.
Yeah, the same way. So now you have this rectangle, and when you get this point, so first you will get that, okay, this is my R2, belongs to my R2. And now within that R2, what will be that point? Because now you for R2, you have the starting coordinate and the bottom left and top right, right? So by using that, you can convert into the actual coordinate, which you have to return.
yeah, and also in this rectangle, the R2, whatever we have selected, when we want to select any of the x and y coordinates, we again have to run our random function.
No, here in this case, you don't need to run.
No, we'll have to run. No.
No,
We'll
but
have to run for y-axis, I think.
No,
I'm sorry?
for both of them. Like once we have the rectangle and we have the lower coordinates, then based on the difference, suppose the side length is 5, then I need some random function to traverse that line also, right?
No, so you will convert this into this space now. So you have that point, and you have the starting point for this rectangle. So you will just update based on that. This is your reference point now for this coordinate.
Okay, you
Yes,
have a
but there are
different way of doing
multiple
it. Okay, no problem.
So let's say if somehow by using that you are able to get that x and y, right? And this x, y is based on 0.
Sorry.
And you know that the top point for this rectangle, right? You know this point.
Okay.
Yeah.
So he's trying to do it in a one line, find a point on that line and convert that point in one of the x and y coordinates based on whatever we have, the bottom right and top left coordinates of that rectangle. You're just trying to convert it. Yeah, that also makes sense. Yeah, no problem.
But how do we convert this one point which is in 1D into into x and y axis? I understand that we can convert the 1D point. Let's say the random point returned was 32. Okay, then now we know that the 32 lies in R2, and the x can be considered 2 because it's it's at a distance of 2 from 30 from the starting from the bottom left point. But what will be the y point? How can we get the y point here?
So let's see what he has in his code. So it will be more.
No, I don't have the code.
Okay. Yeah, but actually, see, the way I did, I had to run random thrice because or else we get a lot of errors in some of the test cases. So if you just have one, because then you don't have that uniformly, randomly, whatever the
exactly.
So many test cases don't work.
You just do the same thing for the y. It's gonna be okay.
Why? How will you get then?
He
You
says
do the x as the y.
I think it's you know that point. I think you know that point belongs to the second rectangle, right? And you know the width of the rectangle.
Yes.
Now you can mark with that width, and you find the column.
You can
find a y.
C into R plus C, right?
Yeah, I understand that, Praveen. But if you do it that way, because it becomes something to do with the non-randomly and non-uniformly there. So they have arranged their test cases in such a way that if you don't run that random function twice or thrice, then actually some of your test cases will fail. First test case will pass perfectly fine, but there are some test cases which actually it doesn't allow you to go.
Why?
That is what they have arranged it, So they want to make it uniformly and randomly perfect. So
because I think let's say we have two rectangles R1 and R2 of areas 10 and 100 respectively. Then the entire range will be 0 to 110, right? And if we pick any random point, then the probability of getting that point will be 1 upon 110, right? Let's say that it will be highly likely that the point will lie in the R2, right? Then if we consider that point, let's name that point A, then the probability of getting A is 1 upon 110 and not 1 upon 100, right?
Yeah.
Does this make sense?
Yeah.
Non-uniformity is there.
Yeah, exactly.
So, but for R2 we have 90 such points, right?
R2.
We have 100.
No, we have 100, no?
100 and that should be sum up to 110, right?
R2 is 100 upon 110.
Yes,
right,
exactly.
it should
100
be,
upon 100.
I mean, yeah, it should be 100 upon 110, or you can say that 1 upon 100 because you've already selected that R2 will be the rectangle, right?
Yeah.
Are you choosing the point or the rectangle?
Selecting the rectangle itself, you have to come with something, right? So the probability of selecting the rectangle itself is it's 100 by 110.
Yeah, see, the first thing is when you have to select the rectangle also, if you just select the rectangle just like that, also it doesn't work. We need to actually search that rectangle using some sort of an algorithm because we'll have n number of rectangles. So that is the first thing we have to do. So you'll have to use something like
the rectangle.
First as a rectangle,
yeah.
And then you get the rectangle, you run for that x and y coordinates, and then you return it. So it is completely uniform and random.
Yeah, I don't get it. Why this one is not uniform? This one is uniform, right? Because we have total space is 90, and we randomly select anywhere between 0 and 90.
Yeah, but you are actually converting. When you are converting it into a point, you are converting it. So it's not a random conversion. Okay, because you have to lie uniformly.
Yeah. So when you get that point on this line, so that will be, uniformly because.
Yeah, I think it's uniform. Why not?
But then, how do you convert it into x and y coordinates if you have a point?
Yeah, so
because you know the width of that rectangle. right?
Okay.
And then because let's say you are on the rectangle 2, and you know that what the width and the height of the rectangle 2. Now you know you can find the coordinate of x and y.
But in the same way, you can actually find with a different numbers, you can find the same point. You know, even if your
No,
number is different, you
no,
can
you
have
will.
your.
Hang on. You cannot. See that. Okay. For this point, so first you have right now the reference point is here based on the 0, right? So first you have to actually you need to get this distance from here, because now this belongs to R2. So what is the distance within R2, and how will you get that? You know the right top right for the R1, right? So when you know the top right for the R1, so you will actually subtract that part. Now you have this distance only, and now based on the R2 bottom left, you will add that to calculate that. So this point will be only within that R2, and that will be a unique point.
Yeah, I think, well, logically everything looks fine,
The point
but
is
if
very
you do
simple.
it that way, you know, so I think what they are trying to say is first you find a rectangle randomly, and in that rectangle you find an x coordinate randomly, and in that again you find y coordinate randomly. Okay, so then there is a very uniform distribution of random points. That is what I think they try to say.
Yeah,
I
actually, yes.
understand what you're saying, Praveen.
No, because if you
No,
do that way, and then like you have two rectangle, one rectangle have only small small area. The
No,
second rectangle have
for
big
that,
area.
no,
Now you
for
select
that,
the rectangle, that would be incorrect. It's
no.
not uniform distribute.
Yeah. For that, you need to have a prefix sum for all the arrays. You know, it's not just like that. So we have to pick up the rectangle also based on random selection of a uniform way. If you have a prefix sum for each and every rectangle in an array, then you are actually distributing it very perfectly well. So that also you have to do. That is first
And
thing
this
what
is
you have
the
to do.
distribute. This is a prefix sum we're talking about, right? I think that's the one that Praveen drawing a type of prefix sum.
Right. That is correct. I'm saying that he is doing it exactly the way. So for your question, when you said you are actually want to find in a particular area, so for that we have to have that first pre-calculated. And when you find that, so when you are actually generating a random, you are actually selecting a rectangle using that prefix sum, and then inside you have to do those two random functions. So if you have something to share, I'm fine. We can actually go through that also, Leon.
No, I don't have it. But
no, I don't.
Because I tried it that way, because that is what I also came up with. Then I found it very frustrating. It's not passing most of the test cases. Then I started looking into other things. So I found this is the way it works.
Yeah, let me code that and I'll share it within the channel.
Please, yeah, no problem.
Yeah.
Meanwhile, can you share the code?
Yeah, sure.
Let me stop sharing.
Yeah, before Shashank goes, I'll just quickly share mine. Okay, I wrote some of those functions which actually. Okay, so I just wrote some of these functions. Well, so this is an array which I'm using for this prefix sum to actually store all our areas. Okay, and this is the input which I get from that constructor, and my constructor is over here. So this is the solution, which is a constructor. I'm getting this rectangle over here, and I'm calculating the prefix sum by actually looking for each and every rectangle's width and multiplying that by the height. Okay, and then I'm actually adding that in this one. So every time I actually go and create this prefix sum array. Okay, and then I initialize my rand function. Okay, with this is a C rand function in C++. And then when I come to this pick function, okay, So now I have this total sum. Actually, it is a complete sum of all the arrays, sum of all the areas of all that arrays. And then actually I run this rand function with modulo of sum. Okay, and then I pass it on to this least greater. This least greater is nothing but it's a binary search. And I'm trying to search through all of this prefix sum what we calculated in all of them. And it will try to find in which point actually this prefix sum, this value will lie. Okay. So either you use that upper bound, what we use in C++, but I just wanted to find how exactly we can do it. Therefore, I actually went in some forum and got this least greater. And then actually when I'm done with this, so actually again I run a rand function here. Okay. So when I'm doing that, I find it for X coordinate and Y coordinate. And then I return those.
Great.
Okay. So this is actually went through some of the code and then I got these things. But I was also doing it the earlier way what they were discussing, but it was very frustrating, so I left that. I'm sorry. Go ahead.
Any reason for specifically using the srand function instead of using the random function like rand function in C++?
Well, actually, this seeds with based on the time what you generate. What actually your time is. So it will always, whenever you start it again, it will always give you a different set of points.
Okay, so is there any benefit? I mean, if we use the rand function, if we directly use the random function,
you can use random function, but this is what actually starts with it. It gives you a seed, so you can have something to seed with. You can have a very static, integer value, or if you give a timestamp value, that will always be great because it will take from that timestamp, and then it will give a very good uniformity. That is what I found out many times.
I think it will make static for that particular time frame, right?
Right. It will start from that. Yeah.
Yes. But I think you have used rand only, in line number 89. You haven't used srand.
It's just for srand is just for like starting. After that, you can use rand directly.
Yeah, it's only for the seeding. Yeah.
Okay.
So I just
I used the upper bound function.
Yeah, exactly. I was also using the upper bound function, but every time we go through the upper bound function, I was always curious to understand how this is actually internally implemented. So I went through one of those, I think, Geeks for Geeks, and I found this one very helpful because every time we have that problem, in a binary search, which way we should go and how we should select these values, right? So I wanted to really understand it. So I got this from them. So it was very helpful. That's the reason. But upper bound actually works perfectly fine. You don't have to do it this way. But this binary search actually it becomes very critical in some cases when you are trying to implement it. And if it happens that when you go to someone asks you how this upper bound function is implemented, or you need to know more about it. So there are different variants in of binary search, which Geeks for Geeks actually has explained very well. So I just used one of them, and it was helpful. Yeah. Okay.
What is the space and time complexity for the code?
Okay. So,
binary search should be okay.
Yeah, so that will be log n, right?
Into number of queries.
Yeah.
Into the pick function.
Yeah, so for creating the prefix sum will be O of n for sure, and that will be a space also, O of n. And therefore pick actually will be running a binary search, log n and multiplied by the number of picks. Yeah.
Okay.
So problem exactly similar to this was asked in one of those lead code challenges. Exactly similar.
Really?
So
When
random pick by weight.
Pick by weight. Okay.
I would share the link.
Yeah.
But there also you need to reduce the weight by. After picking, you need to reduce it.
Yeah, but there also we we are mapping the indices based on the weights given, right? And then we are using binary search.
Yeah, I mean, I just wanted to say that there you need to, I mean, after the element is picked from that particular weight, you need to reduce that weight as well.
Reduce.
Oh, so you don't want to take that weight again into consideration. That is what he's trying to say, right?
Yeah.
Okay.
I mean, basically by -1 or something like that.
But then the problem statement might be slightly different.
Not really,
Yeah,
not really.
definitely.
That's the implementation.
Okay. Then please share that in our Discord.
Yeah, sure.
And then actually
Discord, yeah.
Yeah. Shashank?
Yeah. So actually, my implementation is not correct. So I think what I saw in the discussion was similar to that of yours. Yeah. So I'm switching to next then. So it's like a snapshot array. We are given a snapshot array that supports the following interface. Snapshot array will initialize an array data structure with given length, and initially each of the element is equal to 0. Then set function is there whose return type is void. We'll set the element at given index to be equal to the value, and snap takes a snapshot of the array and returns the ID of it. That is total number of times we call snap minus 1. And a get function will return the value at given index at the time we took the snapshot with the given snap ID. So for this, if we look, we have snapshot array 3. So which says that, I mean, you have to set the length to 3. And here 05 means at 0th index, you need to put 5. And snap means you need to return the ID at that particular snap. Like when you take a pic, what is the ID? And then again, it's setting like at 0 index, it is putting 6. And get is like get the value of 0 with the given snap ID. So return 5 in that case. Because at 0 index, we are having the value of 5 and ID was 0. So your snap ID was also 0 and value at array of 0 was 5. And get function means it will return the value of 5 to you. And coming to here, like at most 50k calls will be made to set, snap and get. And value will be less than 10 to the power 9. And snap ID will be, I mean, it should be less than total number of times we call the snap function. Yeah.
Yeah, so in this case, when you say snap, actually it stores some of the state of that current array, right? And then actually
at particular instance, yeah.
And that is frozen, and then you start with the next level, something like that.
Level.
I inferred it as at that point of time, but not a previous state as such. Then from the test case, I got to understand that it has to be based on previous state.
So you are saying that it is not supposed to be related to the previous one, right?
I inferred it like that. I mean, each snapshot should be different, but yeah.
Yeah, so you start with that. Yeah, it looks like that, just reading at the problem statement.
It is for that particular current instance, right? Snap.
No. I mean, if you take one snapshot, it will be based on 0 as well. I mean, as per the question, but I treated that the first and 0th snapshot. I mean, the snapshots can be different. I thought like that.
I was also thinking like that.
Snapshot is just like a snapshot. Actually, just take a snapshot or a baseline of any of your code and then move on.
Now it became
baseline, something like that.
very. Yeah, we can take multiple snapshots at the same state. Multiple times. At the start. Now it became very.
I think voice was not clear.
I didn't hear Dilip what he was talking.
Hello.
Yeah.
Hello. Can you hear me?
Yeah.
Sure.
Yeah, I was telling we can take multiple snapshots at the same state. Then we should have multiple snapshots, right? Like, for example, if the given input is something and we take the 3 to 4 snapshots at the same point, each snapshot each snapshot should have all the same values.
Right. Yeah, that makes sense. So if you are not doing anything, you are not setting any value in between. So and if you're just taking snaps, 2-3 snaps, then all the snaps will be the same. Yeah, that's right.
So I just thought maintain a list of lists, and whenever you try to set a value, you add an element in that index in that list, and when you get the snap ID, that gives the index in that list. But because of this problem, that didn't work.
But then are you trying to store the array somewhere or?
Yeah, I'm trying to store the array with a list of lists. Like each index is a list again, which stores the values. Every time it changes, it stores the next value in that. So I thought all snapshots are unique. So every time a value changes, then we will take a snapshot. But sometimes we need different snaps of the same value. So
when you start with a new snapshot, you just initialize to the last snapshot.
Yes, I mean last.
So, but when you actually get the value, you will have to get it from some other snapshot also.
Yes, that's what I'm saying. A new snapshot. Suppose the snap function is called. So the snap counter would increase. So the moment we increase that snap counter, we should simply reinitialize this with what we have just left to this snap, like snap -1.
That you have to do for the all elements in the list. Like at the all index, you have to do that. Right? Like for example, we have 3 elements in index 1 and 5 elements in index 2, and you try to take 4 snapshots in there. Then this will become 7 elements, and that will become 9 elements. And if someone asks you for the 6th snapshot, then how would you know which index you need to go in, which element you need to go in which index?
But that is true. That is what is given in the get. If you look at the get function statement.
In there we get the snap ID. But what does it mean in like if we are storing each index means a list of all the snapshots, right? In that index values which are changed.
Yeah. But
so
one thing.
So I implemented such a way that my index in index in list gives the element in that snap ID.
But if you implement the way you are saying, if you use a list, so you won't be able to access it with O of 1. All right. So if you do that way, then you'll have to go sequentially to find all those.
Get would be off one, right? Like if I want the second index snap ID of 5, I go to the second index list and get the 5th element in that list.
Oh, you said list, right? So therefore I was thinking it was a linked list. And then, okay.
Python list or like
array. Python list. Okay, array. Okay. Yeah, got it.
This is for inters or?
So so
inters.
Do you want to? Is it clear now, or do you want to go through the problem statement again?
Yeah, it's clear.
Okay. No problem. Thank you.
So I made use of a map.
Okay. Yeah, you want to share that?
So,
Arjit, could you please, increase the font a bit? Sorry about that. The slide. Yeah, that's enough.
Is this okay?
Yeah, that's fine.
Okay, so we have 3 functions here. One is the constructor, 4 functions, sorry. Then is the set function, then the snap, and then the get function. So get is relatively simple. So what I'm doing is I'm obtaining a map of map, where the key would be the snap value, snap counter value, and The rest part would be the index. So I go to the snap and I go to the index and I put the value.
Okay.
Yeah. So I initialize my this object with snap counter is 0, and let's say snap is called. So I increment my snap counter, and this is what I was talking about. So when you move to the next snap counter, we have to store this with the previous snap counter value, like by default. If we do not change anything, then the value would be same. Now I return snap counter -1 because it says that you have to return something -1. Yeah, -1 here. We call snap -1.
Yeah, so you have to return the previous snap counter value. Okay.
Yeah, so this thing. So initially I tried with a vector instead of an unordered map, but I was having problems in setting this because in the vector we just do pushback, right? So I was not able to go to that particular index and set this as value.
Oh, okay.
I posted this in the group also.
Okay.
I was using vector, and actually what happened, what problem with me was I'm getting TLE. So again I come to this map things, then it passed.
Yeah, runtime error.
Okay, I can show you my, I mean, just explain, first you explain this, I can show you, I mean, I was not getting any error in initializing with the vector itself. We can discuss that one, but just now you can explain.
How do you handle this thing when I ask to go to a particular set of value? Because we cannot define the vector size, you know.
I mean, see, there is a length, right? It is given already initially. Initialize an array like data structure with the given length, and it should be equals to 0.
Are you
I
sharing
mean,
the
you
code?
want me to share? Wait,
Actually, let's finish yours first, Harshit.
Let's finish yours. Meanwhile, I will get that code.
Yeah. On line 18, is it like clone another map, or is that like a reference to another map?
I think it's by value. It's not a reference.
So clone a new one.
Yeah.
Harshit, is it a copy of the? It's a complete copy.
Yeah, I think it's a complete copy.
Okay.
But why do you have to do that actually? Because you're already storing it based on your key, right? When you're on your line 13, you're already doing that, correct? You are taking the snap counter, which will be your first key in that whole scene, right? The main level key. And then you are having an index, which will be your second unordered map, and then you're storing the value. So that will keep on incrementing. So when you go for the next counter, when you have a next snap, okay, you just increase the snap counter, and that should be fine. You should not have to use this 18th number line. That is what I think. Maybe I'm wrong.
I'll do an example where this failed for me. I also thought the same.
Okay.
So it's this thing. So we start with this. We set at the 0th index 15, and then we call snap thrice, right? And then we go to this at the what is this index and value.
Okay, it doesn't have anything there.
Yeah.
Okay. Yeah, I got your point.
So I have to store the state of my current.
Yeah.
Sorry, could you repeat that like this one? I didn't get this. Sorry.
Yeah. So when I'm moving to a new state, and if I do not store my array, which is there at that point in the new state, then if I call this get function at some point for that particular new state, I won't have any value.
Okay. But can we do something like, if we don't have any value, can we recursively call, decrementing the snap while returning it instead of maintaining a copy?
Actually, you can do the I mean, if you store, yeah, actually you
Even
can do.
like, yes, we
So
can do. Even if,
yeah,
like, upper bound we can use. Actually, I've used this without initializing the another set kind of thing again and again, and I was able to do that.
so I
Yeah,
think you can do what you were saying, like going back and changing only the differences, like only when the set function is called, storing just that and then going back. I think that looks feasible.
yeah. Because Arshit, the thing what might come in interviews, they will say you're using extra space there, which can be
Yeah,
avoided. No?
yeah. So the
There
remedy
might
is
be
to
a,
go to the last snap counter, right?
yeah. So just go. Someone was saying, right? Sandeep was saying you can go back and actually find out.
Yeah.
Yeah.
So does it make sense what I said? I mean, I'm just we can go back, right? Like if we don't find it in the current snapshot, in the get we can go back and find, right? I'm
Yeah,
just
we have to go to the any value which is the latest one.
okay.
Because if you don't find that snap ID, you go down to the latest snap ID where you have a value to find value, and then you return the value. Yeah, that is fine. That works.
Okay.
But in the get function, we give the current snap, right? Current snap counter.
Yeah, you give that, but if you are not able to find it, so you start a while loop to find an snap ID where you have a valid snap ID, and then you find if you have a valid value, and if you have that value, you return that.
Right, right, right. Got it.
Yeah,
Got it.
that should work.
Okay.
Yeah, yeah. This is taking a lot of space, yeah.
Yeah, it is good implementation, but the only thing they might ask in an interview saying, okay, just want to actually find out, how best we can optimize on the space also. So that might come up.
Right, right. Yeah.
Yeah, it looks good though. Yeah, everything is fine. It's very concise that way.
Yeah.
If you don't have to use that, if you have to use 18, then it's very perfect. Yeah.
Mm.
Cool. Yeah. Yes, I think Nitish wanted to share something, right?
Yeah.
So coming to the initialization part, right? So actually I got this TLE. I used like a vector initially itself. So this how should I initialize it? I mean, I
Okay.
don't know where we are getting error. So can you see this?
So you are getting a TLE, that is what it says, right?
Yeah, TLE. So this actually gives me TLE.
Mm-hmm.
So I come up with something like this one. This is the latest one, right? Yeah. Okay. Yeah, this is the code. The same thing, what I have done,
Mm-hmm.
like an ordered map of map I have done. So this index will keep the, I mean, snapshot ID, and this will be the index, and this will be the element itself.
Okay.
So this will be, so this will be the index, this will be the index, this will be the snapshot, or this will be the value. Now suppose I can explain with example. So what happens if somebody is setting for the some index, right? Like index one, and for index one it is setting value to 10. So what I am doing for data in this index, snap ID will be like, we will be having the access of snap ID every time, right? So it's like internal value will be storing the snap ID, this will be 0.
Uh-huh.
So at the beginning, so at index one, snap ID 0 will store the value, right?
Okay.
And whenever they are asking snap ID, I will increment and I will give this. I mean, like it will be returned first, then it will increment. It's like a, right. So
Mm-hmm.
returning this, how I am returning this, right? Actual value. Now suppose if somebody asked me get me for index 3 of snap ID 5, supposedly. So what I will do, I will go with this index first, and I will see whether this index has that element with snap ID or not.
Okay.
If it is not there, right, this upper bound, what will happen? Upper bound always return the next greater element to that. Suppose I'm asking snap ID 5, I will get the snap ID 6. Okay. So if it return me something, begin means like it is not returning me the like the, I mean, if we find some element, right, so this won't be a true. It will
Right.
be,
Edge case, yeah.
if you want to be in the begin, it will be somewhere after the begin, right?
Yeah.
If it is in begin, if I'm coming, that means for that index we haven't initialized any value till now.
Okay.
So I will return 0
Okay.
for that.
Yep.
If I found something, right, so I will return just back of that value. So you might be asking why I haven't gone with the lower bound, right? Why I have choose the upper bound, right? So actually how it works, lower bound and upper bound, I can explain you.
But won't that snap be always be there?
Sorry?
Won't that snap value which the get function is passing always be there?
Yeah, but in case if there is no value for that index in any of the snaps, so what to do? I think that is what is the worst case is trying to handle.
Yeah, this one you are asking, right?
Yeah. Harsh's question is, there will be a snap value, right? At least.
Yeah, snap value will be there, right? That's fine. This snap value will be there. So I'm not talking about the snap. I'm talking about whether this index is initialized or not. For each snap, that index might not be initialized, right? So it will be default 0.
There won't be any index at all. There's no value stored at all for that index, but they are asking that value. Okay, got it.
Okay. Okay, so then you go to the previous.
Yeah.
Yeah, but if
I
he
mean,
finds that index, then he will go to the previous. If he doesn't find that index, because there is no set called for that index at all. So then
because see,
what?
why I'm calling this previous, right? Because this upper bound works in that way. If I was going to the lower bound, right, I'm missing some corner cases. That's why I gone with upper bound. So you can read through this upper bound, or I can.
So we have the snap ID and we don't have the index, I mean, populated at that snap. So wouldn't the previous snap, I mean, it take the value from the previous snap?
But if that index doesn't have at all, it's not called at all. So even
That
if
index has never been initialized in the slide, right?
Okay.
I'm taking this here, right?
Got it.
But that index has never been initialized, so I'm returning 0.
Yeah.
If it is initialized somewhere, then I'm returning just that element.
Yeah. Okay. Yeah, that's a corner case to consider. Yeah.
Okay.
Okay. Yeah, that's good.
So I think compared to previous approach, so we are maintaining a snapshot, and each snapshot we are maintaining integers values, but here at each integer we are maintaining snapshot, right?
Yeah. So everyone using different implementation.
Yeah, it's like two complete different. So which is a space optimized? I mean, any idea, like,
both are actually space optimized. Yeah, the way you actually implement inside, right? It depends on that.
When in terms of, I mean, if can interviewer ask, like, if there are more number of snapshots, like which operation would be better? Like, I mean, I'm just unable to think. Like, I'm asking.
Okay. Okay.
But
But then you'll have to find out, like, every time if you are actually storing the whole array, then it might be more space consuming, right? But if you are actually storing only those values for a particular snap ID and an index, so whatever way do you implement, that's fine. So, but you have to visualize. His visualization was different. He was taking index 1 and then he was actually using all the snap IDs inside it.
Yeah,
But
I mean, I couldn't even think.
Harshit was doing it a different way.
Yeah.
Okay.
So I think he's doing it in a better way, because I was populating the entire array for a new snap, right? You're not.
Yeah. Yeah, but initially I will also do the same way, but this will be slightly, yeah, okay. When I'm using it for some time, I'll understand, okay, I could, save more space, or I
Basically,
have a
this will
different way.
take equal number of spaces as we have this set method, right? So the number of, I mean, it's totally depend on the value. How many value we are setting, that many space it will consume, right? There is nothing like cloning those elements in the next snapshot.
Yeah. So in
Yeah.
Harshit's case, if you avoid the line number 18, then he could also come to this place only, but only thing he'll have to actually enhance his get function.
Yeah.
Yes, I
So then
mean,
it will
yeah.
also be almost the same implementation. I think that you're also
So
almost doing the same.
basically, he has to modify this snap function and
And the get function
accordingly
also.
get.
Yeah.
So this get and snap is tightly bound kind of thing, right? If you temper the snap, definitely you have to change the get. If you temper the get, then you have to change the snap.
Yeah, I agree. Yeah.
But this upper bound makes the get operation little costly, right?
Yeah, it's exactly like a login times. Yeah, internally this
But
map, right?
But
yeah,
you will have to, because if you have a lot of snap IDs, so you'll have to have either you iterate through the whole snap IDs or you use an upper bound. So upper bound might be more efficient to use, I would say.
exactly.
But only thing is you are having a map there, right? So when you're saying unordered map and map, so you are using map and then therefore you are able to use upper bound, correct? Because that is ordered one.
Exactly, because I want this, right?
Yeah.
Where I want to know where, I mean, till where I am here. I mean, till where I am right now.
Yeah. Yeah. There are trade-offs there also.
There are actually people doing without this binary search as well, but the times are actually better. I mean, so
Right.
people, yeah.
So because what you do is you have an instead of map, if we have a not ordered map, so when you have a snap ID, when they give you a snap ID for get, okay, you have a baseline to start with, okay, and from that actually either you do an iterative way and then just find out. So that might also work, but it depends again.
Yeah, someone actually, Sandeep or someone said, right? Actually, people are, I mean, that has a better runtime than this, I mean, tree
Upper
map,
bound.
yeah, tree map or binary search based solutions.
Yeah.
If you go
But
with the unordered map, right? So I'm not still getting, I'm not very convinced how you will be getting those, I mean, value according to the snap ID. Because it won't be in order. The value stored won't be in order, right? So
So,
either you can do each snap ID, you have to store something, right?
yeah.
I mean, and suppose if you are searching for 3, if you don't find, then you have to go look for 2. If you don't find, then 1, right? So it's
yeah,
like you have to iterate through whole map itself.
No.
I mean,
Actually, people tried some optimizations like so they are trying to do store only the modifications. Let's suppose the set is 0, 5 and 0, 1, 6, let's suppose. So they are trying to store only these modifications, and they are trying to store this whatever the snapshot size at that snap.
okay.
So
anyway,
0, 5 and 1, 6, they store it. I mean, all the modifications, they store it in a list, and at that snap ID, they maintain the size. So if there are no modification, the snapshot size remains the same itself.
Yeah. There might be something last thing to actually squeeze in to get an optimized version. Yeah.
Yeah.
Yeah. But yeah,
So
all
Nitesh,
are good.
yeah, yes, Santosh.
so do you go back, like for example, my snap ID is 5, and uh, I've called the get function.
Yeah.
Then you're not filling the snap ID 5. I mean, altogether,
Yeah.
right? You are
One.
retracing.
No. One. Yeah. So
So
one
your
minute.
voice.
So So whenever you are calling a snap, they are storing that size of the indexes that, I mean, how many modifications they have at that point of time. So they are going
No,
through the modifications back in time.
that I understood. I'm asking in reference to Nitesh's code.
Yeah, yeah. See, every time whenever you write a value, so that has to percolate to any snap ID, correct?
Right.
Unless and until you don't overwrite it. So
Right.
even if you have the latest snap ID, you still have to have that value even if you are not disturbed in previous snap IDs.
Yeah.
So for that, you will have to go back. If you don't find it in a particular snap ID, you will have to search for the lower snap IDs to find a value, because that is the value which you are actually starting and building the whole array. Correct?
That is happening on line number 20.
Yeah, that
20
is
is
actually.
actually,
Yeah.
Previous of IT.
I
Yeah.
mean, it's not about 20 or everything is 19. This 19 line number is important actually together in there.
Yeah, the
This
19,
is
19 line number is finding the iterator actually, where
yeah,
the
yeah.
snap
But,
ID will.
but at line number 19, like, why are we not checking if the index exists before trying to do a upper bound?
Anyway, okay, I will get to your point is because if you will do it right, suppose it's like a getting, I'm including those things implicitly. How I will tell you. Suppose this index is not exist, right? So definitely what will happen, this iterator won't move anywhere. It will stay pointing that, I mean, data map array itself, right? I mean the pointer to data map itself, right? This reference actually. So this
Okay.
will be valid.
Okay. So the begin.
That's
Okay.
why. Yeah. So it will remain begin itself, right?
No, but that is true. But what Sandeep point is, if before line 19 itself, you could check in the data map if the index is
Even
present.
okay, I got you. What he is trying to is
Yeah, yeah.
you can do this, no issue. But the thing is, I am already taking it into.
Absolutely, absolutely. You're doing that. Yeah, you're doing
Yeah.
it.
Yeah.
There's
Yeah,
no
because
problem.
I think, I mean, like other languages, if the index doesn't exist, like if you're trying to check, it will maybe, error out, give an error there.
So
Yeah,
this what we are trying to say, right?
correct,
Yeah,
correct,
yes, correct.
correct.
Actually, the thing is, it is all implicitly it is covering. So I
Yeah,
haven't
I
put.
understood. Okay. Yeah, like it's a language
Actually,
specific.
I mean, yeah, it's language.
Okay. And the other question I have is like let's say if we have like just one value is like one index value is set, like which is like in the first example 0, 5, and if like
Okay.
if snap is called like maybe 10,000 times,
Yeah.
but we are incrementing snap like 10,000 times right here.
Yes. Yes.
Okay. So
So how it will work, right?
yeah, I'm just
So
thinking
what
like
will
I
happen?
mean what like
Yeah, I will.
okay.
How it will, I will explain you. So right now my snap will be 1,000, right?
Mm-hmm.
But I'm searching for the index 0 and snap 1,000 and I want that value, right? So
Yeah.
what will happen, this upper bound will be go to the end of that, I mean, map, right? Because
Yeah.
it is not finding anything, because 1,000 is, I mean, no element is with 1,000, I mean 1,000 snapshot, right? Are
Oh,
you
got it.
getting me?
Okay, okay, okay. The last value in upper bound is like 1 or 0. Yeah.
Yeah.
Zero, yeah, yeah.
Oh, okay, makes sense. Okay. So even though like you're calling multiple times, the upper bound is taking care of optimizing it.
Yeah, it is
Exactly.
doing a binary search inside it, yeah.
Oh, okay, okay. Yeah, yeah. I think okay.
So basically this, I mean, though you are increasing the snap, right? It is not increasing your this map.
Yeah, yeah. I'm just trying to compare because if you are like
Yeah.
using the earlier approach, like even if
Hmm.
you're maintaining a delta, so we were like thinking like if the uh, if the particular index is not found, we were thinking to recurse back to the previous one, right?
Mm-hmm.
So
Yeah, yeah.
in the previous one, like we may have to recurse like 10,000 times to get to actual value.
Exactly,
Yeah,
because
But
that time we are storing 1,000 times.
yeah.
yeah, right.
Yeah, yeah.
But here in
Because
this
we are
case,
making it
okay.
yeah, copy of 1,000 times. Whenever in that approach, whenever we are calling snap function, we are actually copying the previous snap to the current snap, and then we are changing whatever you want, right?
Yes, yes, yeah. Okay, yeah. I think
Yeah,
in
but
that
here
case,
I am not.
like this upper bound is like helping us, giving.
Exactly.
Yeah.
Thank you.
Yeah.
See,
That's
actually,
good.
it's sometimes becoming very difficult to explain because we don't have board, right? If it is board kind of thing, then it will be very easy to explain.
Yeah, you can
Everything
have
we
a
have to
board,
do is through.
you can actually go to that, and there is a whiteboard in Zoom also. You can take that help.
Okay, but through mouse it will be there, but it's not very.
Okay, okay, no problem. But this is good. Yeah, we like that. Yeah,
Yeah,
no problem with it. Thank you.
no, thank you.
Yeah, thanks, Nitish. It was helpful. Yeah.
Thanks, Nitesh.
Thank you, sir.
Yes.
Bye.
Shashank, your co-implementation.
No, I haven't like coded this.
Okay, no problem. So I think, yeah, let's call off today.
I think just like one last. So when such kind of things like an interview, it is more talking about the trade-offs, right? Like which approach you take on what kind of trade-off you get.
Yeah, it's difficult to say,
You
but
can stop the recording.
Yes.
yeah, you can stop.
Santosh,
So
Actually,
you are the
actually, we have seen two solutions right now, right? Just before me, one solution was where I think Harshit has presented the solution, right?
Yeah.
So that solution actually was, if you come with the time complexity, that was really good. Actually, it was taking, you used to get in order of one, right? Because an
Yeah.
ordered map of an ordered map was there, so you are getting constant time.
yep.
But if you go with this space complexity, it's like we are making lots of, I mean, we are consuming lots of space unnecessary, like cloning all those things, right? If even though it is not sent, but we are still cloning all those things, forwarding to the next, I mean, snapshot, right?
Yeah.
So there, if there the memory space, I mean, space complexity was high, but in my case, get was never order of one, ideally. In worst case, it can go up to some log n of snapshot, I mean log of snapshot kind of thing. But the space what I'm consuming here is exactly the number of value that one I want to store actually. No, nothing extra I'm consuming, right?
Yeah. Okay. Yeah.
Yeah, but Shandeep, actually, to answer your question, it would be like whatever the trade-offs are, first we should ask the interviewer, right? So whether he is more inclined towards time complexity or the space, here you cannot actually say both of them together.
Yes.
Yeah.
So
True.
you have to somewhere you have to compromise something to get something,
Yeah.
Yeah.
and you have to tell them very clearly this thing.
Yeah, because I'm just thinking that, such kind of things in an interview, like, I mean, in a lead code, we have all the description, like, in an interview setup, it would be like tough to get that idea or like, uh,
Yeah, it is better
Absolutely.
to
Yeah.
ask interviewer everything. All the so interviewer will never will give you the everything in beforehand. He
yes.
wants you to ask those things. He wants that I mean those candidates should ask him actually. So you
Yeah.
have to get the conclusion of the all the boundary cases, everything with the consent of him.
Yeah, but what Sandeep's saying, we do all this thing over here because we have the help of these lead code tools and everything, right? So how we actually should get in that interview, all these things in interview. So
Yeah.
because we have a time constraint, we are slightly stressed out over there and all those things. So, but I would say, the best thing what we are trying to do now is we are trying to discuss various approaches, right?
approach.
Yes.
So we discuss more of these, so we understand and we try to actually talk to the interviewer at that time, because the more we understand, we have more all these pointers. It helps when we are talking the interview. That is my experience. I think
Yeah.
it
Yes.
helps. That's
I
what
mean, I
we
agree.
try to talk more and understand each and everyone's approach and see how we can actually dive that.
Oh, yes. Yeah. I mean, definitely, like, this last question gave me a different perspectives, like how to think.
Yeah.
Yeah. It was good discussion. Yeah.
What will you
That
say?
is the only way I would say.
Yeah.
Yeah.
All right.
What you said is correct, but do we remember all this after some time?
Santosh,
I mean,
you are the host. I think you only have to.
Oh, sorry.
Yeah, yeah.